Hello, grade 6. Today we are talking about finding the area of a triangle or parallelogram in the coordinate plane. To start this, let's do a very quick review of what is the area. What is the area of a triangle? What is the formula for an area of a triangle, and what is the formula for an area of a parallelogram? I'm going to pause the video real quick and let you think of these real quick and type these into the answers. Go! All right, now it's time to check your understanding. The area of a triangle is 1/2 times the base times the height. And probably you have this down pat already. The area of a parallelogram is also quite easy. It is the area of the base or times the area of the height. And of course, you can use other words for these as long as you realize that it's the area of one dimension multiplied by the area of the other, the height times the base. All right, now let's move on to a problem. All right, here we are trying to find the area of a triangle. Now, before we even start this, we need to figure out the dimensions, of course, the height and the width. What we're going to do first is I'm going to call this the base. You can call it whatever you want. I'm going to call this the base, the distance from here to here. And then the height, I'm going to call the distance right down here. This is the height, the distance from here to the perpendicular height there. It doesn't really matter as long as you multiply them together and divide them by 2. It doesn't matter what you call them, base or height. So let's look at the red first, and let's find this distance. There are a few ways to do it. I'm going to show you the easy way first. If you're looking at the height, we're moving up and down. I'm looking here at this number and this number because this is the y-axis. The one that moves up or down is the y-axis. And these are, in the coordinates, we have x comma y, and so I'm looking at the y number. So the easy way is just to figure out, well, how far is it from here to my line? Well, that's 4. You can see that from the number. And then similarly, how far is it from here to my line? And you can say, well, that's 3. And if you add these together, you get a height of 7. That is one method. I'm going to show you another method. The other method is using a little bit more math skills. Anytime you want to find the difference, the distance between 2 points, all you have to do is subtract. So I'm going to take the 4, and I'm going to subtract. And the other number is a -3, and if you remember back to our techniques, this subtracting a negative actually turns into a positive, and I end up with a 4 plus 3, which is 7. Hey, that's the same number we had before. Isn't that cool? The other thing is, what if we did it the other way around? What if you started with -3, and you said, hey, I'm going to take -3, and I'm going to subtract 4? Well, what would I get in that case? I'm going to get -7. Well, we have to add one more thing in that case. Really, what we're looking at here is the absolute value, the always positive answer, because yes, this is -7, that's perfect, but really what does that mean in distance? Distance doesn't have negative, we're just dealing with 7. So it doesn't really matter which way you do that, as long as you realize that the distance from across the height here is 7. Okay, similarly, what I'm going to do is I need to figure out how far it is the blue distance from this point to this point. And again, since I'm looking at the x-axis, I'm going to choose the x numbers. So I'm really looking to see how far it is. This is 2. This is at -4, and how far is it across? And I could use the first method I showed you, which is to figure out that it's 2 from here to here, and then it's another 4. Since this is -4, it's 4 from here to here, and I add them together to get 6. It's going to be 6. Or I could use the mathematical method and say, well, what is 2 here? And to find the distance, I always subtract, and my next number is -4. 2 subtract -4, which is 2 plus 4, which is 6. So my width here is 6. All I have to do now is plug that into my formula, which is 1/2 times the base, which I'm going to call that 7, times the height, which is 6. That's 1/2 of 42. And that gets us to our grand total. We're done with this problem of 21. How exciting. Awesome. The answer is 21, and my units are units, square units. Let's move on to the next example. Here we have a parallelogram, and if you remember, the area of a parallelogram is simply the base times the height, and again, we're going to do this one a lot quicker. I'm going to call this my base from here to here. I'm going to call my height the distance. It doesn't really matter where I do this. I could do that here. I could do that here. It doesn't matter, but it's my height. It's how far it is from here to here or from here to here. Let's use the bottom one. It doesn't really matter. So let's do this quicker. From the height, this base, the red distance, again, I'm in the y-axis, so I'm looking at my y numbers. I'm looking at 8 and -3, and I'm going to subtract them. I'm going to know that it's absolute value. It's always positive, and I'm taking my first point, which is -3, and I'm going to subtract, because I always subtract, my second point, which is 8. So it's -3 subtract 8, which is -11. And that gives us a height of 11 if I'm looking at the absolute value. So the distance is 11. The height, I'm again using the x values because I'm moving left and right. I'm going to use 6, and doesn't matter which one you use. There's 6 and 3 here. You could also, if you choose to use 6 and 3 here, you could do that. But 6 and 3, I'm going to use my subtraction again. Absolute value over here I'm going to subtract 2 numbers. My first number, doesn't really matter which order I go here. Let's use 6 first. 6. And here I'm going to use 3. And 6 minus 3 is difficult math here, ladies and gentlemen. It is 3. And so the absolute value of 3 is 3. So I have my 2 dimensions. It is 11. From top to bottom. It is 3 from left to right. My area formula says that I need to take the length times the width, or the base times the height. It doesn't matter what you call it, as long as it's 2 dimensions, and that is 11 multiplied by 3. So that means my answer is 33 square units. And there we have the parallelogram. Those topics. This is another ALEKS topic we're going to do in the same video. It's the same thing, but with 3 different shapes. It's finding the area of a trapezoid, a rhombus, or a kite. And so the next question that comes to mind is, can we remind ourselves, what is the area? First of all, what does a trapezoid look like? I'm going to draw that little shape here to show the area of a trapezoid. And that's a trapezoid where it looks a little bit like this. We're going to see if we can remember what the area is of a rhombus. A rhombus is it's like a diamond. And then the area of a kite, which is like an elongated diamond. Pause the video and see if you can think of the formulas that we learned last class. Excellent. The key to this is that the rhombus and the diamond are actually the same. We have the same formula for both, and that is if you have a distance of 1, we call that distance 1 across this way, and distance 2 across this way. The formula is very simply 1/2 distance 1 multiplied by distance 2, and you could call that base times height, or whatever the 2 dimensions is. That is the area of both a kite or a rhombus. The area of a trapezoid is a little bit different and a little bit more difficult. The area of a trapezoid, again, if you have the base 1 here, like this, and you have base 2, and you have a height, the area is half the height multiplied by what happens when you add base 1 and base 2 together. There are a few different ways to memorize this, but this is the formula. Let's do a couple examples. We are only going to do one example for both the kite and the rhombus because it's exactly the same. So I'm going to try to find my 2 distances. Again, my formula is 1/2 times distance 1 times distance 2. And so it doesn't really matter. I'm going to call this distance 1, and I'm going to call this distance 2, and it doesn't really matter. We can switch the numbers. Again, I'm looking at distance 1 first, and so that's in the y-axis. So I'm going to look at my y numbers. I'm moving up and down here, and so it's the absolute value of -6. To find the distance, I'm using subtraction, of course, and then my second number is 2, so it's the absolute value of -6 minus 2, which is -8, which is just 8. So the distance from top to bottom is 8. And again, you could see that if you wanted to just by putting a dot here and seeing, well, how far is it from the line to the top? That's 2. How far is it from the line to the bottom? That's 6. Add those together and you'll get 8 if this method is a little bit confusing to you. The next one, distance 2, I'm going to call it, is moving left to right, moving across left to right here. And again, I'm going to use, then in that case, my x values, because that is the one that tells me to move left and right. So I'm looking for -4, and I'm looking for 6, and I am going to, again, use the same absolute value with the subtraction sign. And my first number is -4. And my second number is 6. And if I subtract these, I get -10, and the absolute value of -10 is +10. So distance 2 is 10. And again, we could find that by taking a look at from here to here, how far is this? And that would be a distance of 4. From here to here, how far is it? And that's a distance of 6. You could add those together and get 10 that way as well, if that's something that's easier for you. Coming back up to the top, I'm going to plug these numbers into my formula, and I get area is 1/2 of distance 1, which is 8, multiplied by distance 2, which is 10. The math is really easy from here. It's 1/2 of 80, which is 40 square units. Problem done. Next one, here we go. This is the very last one we're going to do. Again, my formula for the area is, and I'm going to do this in different colors because it does get a little bit confusing. It's 1/2 of the height, and then I'm going to multiply that height by what I get when I add together base 1, and I'm going to add that to base 2. Now, base 1 and base 2 doesn't matter, but they're parallel lines. It doesn't matter which one's which. Let's call this one base 1, and let's call this one base 2, and my height is whatever I get when I look across this and the perpendicular height. We're going to call that height. Okay, that's the height. So let's do this again. Let's use base, we're going to look for base 1 and base 2 first. Base 1, and we've done this a few times, so I'm going to go a little bit quicker on this, is the distance from here to here. Again, I'm using my y values, so I'm looking at 3 and -4, and by this point you may be able to see that the distance between these is 7. It's 3 from here to the line, it's 4, and we can add that together and get 7. So base 1 is 7. Base 2, I'm looking across here, and I'm looking for, again, the y values, the distance between 1 and -2. And maybe by this point, it's a little bit easier to see it's 1 here, and it's 2 there. So base 2 is 3. And you could use the absolute value here if you wanted to. My height, I'm looking at how far it is from this point to this. And this is the little bit difficult one. The x value here is 1, because that's where we're at. We're at 1. And this whole line, both here and here, we're at -3. So I'm looking at the distance between 1 and -3. And we can show this here. The distance of the line is 1. The distance here is 3. And so the height is 4 in this case. So plugging this back into my formula, we're almost done. Ladies and gentlemen, you've done so well to get through this point. It's 1/2 times 1/2 times 4 times what happens when you add together 7 plus 3. Well, that's 10. So that's 4 times 10. That's 1/2 times 4 times 10. Well, that's 1/2 of 40, which of course is 20 square units. My area is 20 square units. Hey, this is the longest video we're going to do. This is great. This is a tough one. These are 2 topics. See if you can try them out. Good luck. Let me know if you have any troubles.